Alright guys, let's solve this integral problem. We have the integral of x raised to the power 4 over 1 plus x raised to the power 6 all squared dx. So let's solve this integral, boy. First, before we start this, try to pause the video and give it a try.
Be it unto me according to your word, according to your
Okay, I assume you have given me a go ahead. Alright, let's solve. The problem with this question is that if you look at this question, if you should let u equal to this denominator, which is 1 plus x raised to the power 6, and we differentiate it, if you should let u equal to 1 plus x raised to the power 6, if you differentiate it, we have 6x raised to the power 5 dx. Now the problem is that we need to make the integral more simple, or more simpler rather. Now we have the derivative of u is du equal to 6x raised to the power 5 dx. So we now have, if we should plug this into this integral, we have integral of x raised to the power 8 over u du over 6x squared, 6x raised to the power 5, and it cancels out us remaining x raised to the power 3. And since we are in the u world, that doesn't make sense. So we need the x, all the x's to cancel. So note that this indicates the problem, therefore it's not a nice way to solve it. And if we use trig substitution here, it may also complicate the problem. So let's see, what if we try to reduce the integral to a simpler form such that letting u equal the denominator and such that its derivative cancel out nicely with the numerator, using integral by parts. So of course we still have this integral is just an expanded form of this one here. This integral here. So we just we separated, like we splitted this x to the power 8 into x to the power 5 and x to the power 3. So of course this is the formula for the integration by parts. Now using the integral by parts, which is the formula is integral of f of x g prime of x dx equal to f of x g of x minus integral of f prime of x g of x dx. So we let our f of x equal to this x keep there. So we let our f of x equal to x keep, and we differentiate that, and this f prime of x is just 3x squared. We let our g prime of x equal to x to the power 5 over 1 plus x to the power 6 all squared. So to find g of x, of course we have our g prime of x. To find g of x, we take the integral of both sides. So now, of course, this let's make this simpler by letting of course that's x to the power 5 and 1 plus x to the power 6 all squared. It doesn't matter which letter we use, we put in the denominator here. Of course we let sigma equal to 1 plus x to the power 6 such that d sigma equal to 6x raised to the power 5. That means we differentiate sigma. So we have d sigma equal to 6x raised to the power 5 dx. So dx now is equal to d sigma over 6x raised to the power 5. Now therefore we have that integral of x raised to the power 5 over 1 plus x raised to the power 6 all squared x raised to the power 3 dx is equal to, of course this is just imputing the value of f of x, g prime of x, g of x, and f prime of x from the integral by parts. We are just replacing those values with what we have here. We have our f of x to be x raised to the power 3, so we have x raised to the power 3 here. So we have our g prime of x, sorry, g of x equal to of course after when you get your the sigma, this is equal to 6x raised to the power 5 dx, you make dx solve the formula and plug the values back into this equation here. So therefore we have integral of x, which I color coded red. So we have integral of x to the power 5 d theta all over sigma squared 6x to the power 5. So the x to the power 5 cancel out, which I color coded red. So we have 1 over 6 integral of theta over theta squared, which is equal to minus 1 over 6 sigma. So we substitute the value of sigma, which is initially 1 plus x to the power 6. So therefore we now impute the values of g of x, g prime of x, f of x, and f prime of x into this equation here, which is the integral by parts equation. So we have the integral of x to the power 5 over 1 plus x to the power 6 all squared times x. The x is equal to f of x times g of x, or f of x is x to the power 3. So we have x to the power 3 times 1 over and minus just g of x, we have g of x here. So times minus 1 over 6 into bracket 1 plus x to the power 6. So we have that here. Then minus f prime of x. Of course, assume that there is no plus here, assume that there is a minus sign here. Minus integral of f prime of x. Well, now this is our f prime of x, which is actually 3x to the power 2. And note that our g of x was negative, so that was why I put the plus here, so that this negative sign here cancel out with this, so we have positive sign here. So the integral of f prime of x, which is 3x squared, that is it here, 3x squared, times g of x, which is this right over here, dx. So let's solve this first. So we let I of x equal to that, and all I just did here is that since we have x raised to the power 6, so I make it more simple so that it looks more nice. So we could let u equal to something before we do our u substitution. So we have, of course, using index law, we have x to the power 6 here. Also, it's something as saying x to the power 3 and everything to the power 2. So let's assign type to this value here as x to the power 3. So we let type equal to x to the power 3. So let type equal to x to the power 3, so that the x is equal to the type over 3x squared. Because it's just considering this and making it solve the formula. Of course, it is not actually nice because we don't treat the x and the y's as variables. They are actually the special coefficients. So but it's actually nice because it helps us to evaluate what we want. So therefore we have I of x equal to, now we have 3, look at this, we have 3x squared here, that's it here, 3x squared. So we have 6 into bracket 1 plus x raised to the power 3. Now x raised to the power 3 now is tie from here, so we put tie there, then that raised to the power 2 So we have 10 raised to power 2 times dx, but now dx is this right over here, so we put that value here. So that would be, so we pull out, so you know we can pull out the 1/3, sorry, 1/6 out. Of course, look at the one I color coded red, cancel out. So we have 3x squared, cancel out with 3x squared here, sorry. So now we now have the theta over 1 plus 10 raised to power, sorry, the theta over 1 plus 10 raised to power 2, which is equal to, of course, this integral here looks very, very familiar, and that is the definition for the differential of the tan inverse of the theta. So we have 1/6 times tan inverse of theta, sorry. So our I of x is actually 1/6 times the tan inverse of x raised to power 3. Of course, that is the value of time. So substituting this value of I of x into our original integral, which was this, of course, I said we let I of x equal to this. So the main integral now will be equal to this plus I of x. We found that I of x, which is this integral, is equal to what? 1/6 times tan inverse of x is equal to 3. So substituting that, we have this over here plus the I of x, which we found to be this one in here, and of course we don't want to forget to add plus c, because if we differentiate this, the c cancel out, but for initial value problem, there's no need of putting the c, because you can find the c using the initial value given to you. Thanks guys. If you have a question, put it in the comment section below. And don't forget to subscribe to my YouTube channel and turn on the notification bell so that you will be notified of my next video. And don't forget to like this video too.